Good day, welcome to Jang Amor's channel reserved for meaningful discussions. Today we'll be discussing graph theory for my students since our classes were also affected by COVID-19. So enjoy and keep safe everyone. All discussions in this video are found in the book Mathematics in the Modern World by et.al. Baltazar, Chapter 5, which is our main reference, and Chapter 13 of Mathematics in the Modern World by Sobecki. This is a two-part lecture with the introduction to graph theory and graph coloring in the first part, and Eulerian graphs and Hamiltonian graphs in the second part. At the end of both presentations, you should be able to solve problems on graph theory and identify if a graph is Eulerian or Hamiltonian. Please refer to the video linked below to have an idea how graph theory came to be. Go on, I'll wait. This is Königsberg in Russia, or where the graph theory conundrum has started. The graphs you'll be discussing are not the usual graphs that we see in statistics or Excel or the ones you interpret in science. So please be reminded of this simple fact. So what type of graphs are we discussing? So in graph theory, a graph here is a collection of points we call vertices or nodes, and connecting segments or lines we call edges. Sometimes the edges are given orientations, we call this directional, and sometimes are represented by arrows or are given values or weights. The position of the vertices, the lengths of the edges, and the shape of the edges do not matter in a graph theory. So what we look for in graph theory is a number of vertices and which of them are joined by edges. So if you want your edge to be squiggly line, go ahead. If you want your vertices to be miles apart from each other, then that's also fine. So some examples are a social network of a person. A person is the point, or the persons are the points or vertices, and the connection between two persons is the edge. So if two persons know each other, then you can draw a line between two persons. The molecular structure. The elements are the points or the vertices, and the bond is the edge. So if the elements are bonded together, then you can have an edge between them. The computer network. The computers and the servers are the vertices, and the connection between them are the edges. In constructing a graph, first, you have to identify your vertices. So for example, in this table, the vertex will be the different students, and the edges between them is if the students belongs to the same study group. An X here represents a connection between these two students. So here, Rene has 3 X's, Mads has 3 X's, Alan has 3 X's, Norm has 1, and Kiko has 2. So this is now the graph formed from the table. So Norma only shares a study group with Alan, Kiko shares a study group with Rene and Mads, Rene has a study group with Mads, Alan, and Kiko. Mads has a study group with Rene, Kiko, and Alan. Alan has a study group with Norma, Mads, and Rene. So Kiko and Alan do not have a study group together. So it's a different sort of graph, but this one should be similar to the table shown previously. Here are some of the terms or terminologies that we will be using in graph theory. So starting with a vertex. So a vertex is the point or a node in a graph. So you can represent your people with a vertex. An edge is a line that connects vertices. So this is your relationships. Then we have a loop. A loop is an edge connecting a vertex to itself. So for example, if you go outside San Agustin and go back to San Agustin without going anywhere else, so that's a loop. A vertex or vertices has multiple edges if 2 or more edges connects the same vertices. So for example, from San Agustin to SM City is a multiple edge because you can go via General Luna or via Delgado. A simple graph is a graph with no loops and no multiple edges. So these are shown are some of the graphs that you may encounter. So a simple graph, a graph with loops, and a graph with multiple edges. A graph is connected if there is an edge connecting all vertices. So if you cannot find a single vertex that is not connected to anyone, then we call this graph connected. A graph is disconnected if some vertex or vertices are separated from the graph. So shown are some of the connected graphs and some disconnected graphs that you may encounter. A bridge is an edge that when removed makes the graph disconnected. So shown are some of the ways that an edge can become a bridge. The degree of the vertex is the number of edges attached to it. An even vertex is when the number of edges connected to the vertex is even. A loop is considered an even edge because it's counted twice. An odd vertex is when the number of edges connected to that vertex is also odd. So shown are some examples of how a vertex can be odd or even. Two vertices are adjacent if there is an edge joining them. So in this graph, A and B, B and C, C and D, C and E, E and F, A and E are adjacent vertices. A and D are not adjacent vertices, and so are F and B, because you cannot find an edge that connects these vertices. A complete graph happens when every vertex of the graph is adjacent to one another. So the degree of each vertex then, when this happens, is n minus 1, where n is a number of vertices. So shown are some of the usual complete graphs you may encounter. So if there are two vertices or there are even vertices, you will have odd vertices. And if there are odd vertices, then you will have all even degrees. These are the terms. For clarifications, you may post a comment. So for the first topic under graph theory, which is graph coloring or how to color graphs. To color a graph, one must draw a graph in such a way that no edges are intersecting. This is now what you call a planar graph, as shown. If at least two edges intersect with one another, we now call this graph as a non-planar graph, as shown. These are some of the ways any number of vertices can be placed in a plane or drawn as a planar graph. In any planar graph, we use Euler's formula to determine how many vertices, faces, or edges can be present in a planar graph depending on what is being asked. But usually, it's the face. To use this formula, V plus F is equal to E plus 2, where V is the number of vertices, F is the number of faces, E is the number of edges, then 2 is a constant. If you're looking for the number of faces so that you can draw your graph in a planar manner, you simply identify F is equal to number of edges plus 2 minus the number of vertices. So, for example, if F is not known, but the vertices and edges are known, so V is equal to 6, E is equal to 9, so we have 6 plus the number of faces is equal to 9 plus 2. So 6 plus F is 11. Therefore, F is equal to 5. So shown, there are 5 faces, including the outside face, colored yellow. In graph coloring, each vertex of a graph will be assigned one color in such a way that no two adjacent vertices have the same color. The interesting idea here is to determine the minimum number of distinct colors to be used, so that we can color each vertex of a graph with no two adjacent vertices. The chromatic number is the minimum number of colors needed to color any graph. If a graph is planar, the maximum chromatic number is always 4. Graph coloring is usually used in scheduling problems like this one. So 6 college accreditation committees needs to hold meetings on the same day, but some teachers belong to more than one committee. So in order to avoid members missing meetings, the meetings need to be scheduled during different time slots. An X in the table indicates that the two corresponding committees share at least one member. So to use graph coloring to determine the minimum number of time slots necessary to ensure that all faculty members can attend all meetings. You can pause the video if you want to answer this problem on your own. First, you draw a graph representing the 6 committees using 6 vertices or nodes in any configuration. An edge connects 2 committees that share at least one member. Then assign each vertex of the graph with one color in such a way that no 2 adjacent vertices have the same color. The answer is shown. We have 3 as the chromatic number. Hence, the minimum number of time slots necessary to ensure that all faculty members can attend all meetings is 3. So the schedule of meetings: first time slot, faculty instruction and student welfare; second time slot, faculty development and outreach programs; third time slot, library facility and physical facility. This is the end of the first discussion. For clarification, you may post a comment. So we end the first video here. You click on the link below to proceed to the next part of the lessons.